Hey guys, today we're going to do C.I.E. AS Statistics 1, which is paper 5, and it was written in the February-March session this year. Now on to question 1. It says, a fair red spinner has edges numbered 1, 2, 2, 3, and a fair blue spinner has edges -3, -2, -1, -1. Each spinner is spun once and the number on the edge on which each spinner lands is noted. The random variable x denotes the sum of the resulting two numbers. Draw up the probability distribution for x. So the first thing to do is to create a grid which shows the likely outcomes for the discrete random variable x, which is the sum of the numbers on the blue and the red spinner, and it would look something like this. So we can see from this table that there are 16 possible outcomes, and the possibility space consists of 5 different numbers, which are -2, -1, 0, 1, and 2. So in order to calculate the probability, we're going to count the number of occurrences of the number divided by the total number of outcomes. For example, if you look at -1, we can see that there are 3 occurrences in this table. So this means that the probability of getting a total of -1 is going to be 3 over 16. So after finding the probability for the different outcomes in the possibility space, well, we're going to draw the probability distribution table, and it looks something like this. Where for x is -2, the probability is 1 over 16, and x is -1, the probability is 3 over 16, and x is 0, the probability of x is going to be 5 over 16, and x is 1, probability is going to be 5 over 16, and x is 2, probability is going to be 2 over 16. Now onwards to question 1b. It says, given that the expectation of x, which is the e of x, is equal to 0.25, find the value of the var of x, or the variance of x. So in order to find the var of x, or the variance of x, we use the data from the probability distribution table that we found from the previous question. And based on the formula sheet, we know that the var of x is going to be the sum of x squared p, subtract the expectation of x squared. So we already know the value of the expectation of x is the e of x. So what we're going to do now is to find the value of the sum of x squared p. So that's going to be -2 squared multiplied by 1 over 16 plus -1 squared multiplied by 3 over 16 plus 0 squared multiplied by 5 over 16 plus 1 squared multiplied by 5 over 16 plus 2 squared multiplied by 2 over 16. And that will be equal to 1.25. So now we can be able to find our variance of x, or the value of x. So our value of x is going to be equal to 1.25 minus 0.25 squared, and that is going to be equal to 1.1875. Onward to question 2. So it says, in a certain country, the probability of more than 10 centimeters of rain on a particular day is 0.18, independently of the weather on any other day. Find the probability that in a randomly chosen 7-day period, more than 2 days have more than 10 centimeters of rain. So based on our question, we can conclude that it is a binomial distribution because it's an independent event, and it has a probability of success, which is 0.18, and the probability of failure, which is 1 minus 0.18. So what we do is we let R be our binomial distribution, whereby R is the day, or the number of days that there is going to be more than 10 centimeters of rain. So the probability of Ri is greater than 2 is equals to 1 minus probability of Ri is less than or equal to 2. And that will be equal to 1 minus the probability of Ri is equals to 0 plus the probability of Ri is equals to 1 plus the probability of Ri is equals to 2. And that will be equal to 1 minus 7 combination 0 multiplied by 0.18 to the power 0 multiplied by 0.82 to the power 7 plus 7 combination 1 multiplied by 0.18 to the power 1 multiplied by 0.82 to the power 6 plus 7 combination 2 multiplied by 0.18 to the power 2 multiplied by 0.82 to the power 5. And that will be equal to 1 minus 0.88458. And that will simplify into our final answer, which will be 0.11542. Onward to question 2b. So it says for 3 randomly chosen 7-day periods, find the probability that exactly 2 of these periods have at least 1 day with more than 10 centimeters of rain. So the first thing we ought to do is to find the probability that there's at least 1 day with more than 10 centimeters of rain. And that would be 1 minus the probability of Ri is equal to 0, which is 1 minus 7 combination 0, which is 1 multiplied by 0.82 to the power 7, and that will simplify into 0.7507. Now, in order to find the probability of the 2 periods is going to be equal to 3 combination 2, which is out of 2 days we're going to choose out of 3 days we're going to choose 2 of them where they're going to have at least 1 day with more than 10 centimeters of rain, multiplied by 0.7507 to the power 2, multiplied by the probability of not having at least 1 day with more than 10 centimeters of rain, which is 0.2493, or 1 minus 0.7507, and that will simplify into 0.421. Onward to question 3. So it says, at a summer camp, an arithmetic test is taken by 250 children. The times taken to the nearest minute to complete the test were recorded. The results are summarized in the table. So here's the table. We have the time taken and the frequency. Question 3a. Draw a histogram to represent this information. So the first thing we need to do is to do what we call a continuity correction in order to make our data continuous. So what we're going to do, for example, if you look at 1 to 30 here, we're going to subtract 0.5 from here, from 1 here, which is the lower class, and we're going to add 0.5 to the upper class. And we're going to do the same thing for the others as well. So this is going to be this is going to look like this. So we have 0.5 to 30.5, and 30.5 to 45.5, 45.5 to 65.5. After we have done a continuity correction, and the next thing to do is what you do is we find the class width. So the class width will be just upper class limit subtract the lower class limit. So it will be, for example, 30.5 minus 0.5, that gives us 30. 45.5 minus 30.5, that gives us 15. 65.5 minus 45.5, that gives us 20, and so on. And after that, we find the frequency density. So our frequency density will be our frequency divided by the class width. So for example, we have 21 divided by 30, which is 0.7, 30 divided by 15, which is 2. 68 divided by 20, which is 3,4. 86 divided by 10, 8.6. And 45 divided by 25, 1.8. We then plot the time taken with the frequency density, and our graph is going to look like this, where we have time at the x-axis and our frequency density at the y-axis. On to question 3b. It says, state which class interval contains the median. So since the total number of children is 250, it means that our median is going to be 250 divided by 2, and that will be our 125th observation. And if you create a cumulative frequency, you would see that the 125th observation will be contained in the region 66 to 75. So that would be our class interval, which contains the median, 66. Onward to question 3c. It says, given that an estimate of the mean time is 61,05 minutes, state what feature of the distribution accounts for the median and the mean being different. So what accounts for the median and mean being different is that the distribution is not symmetrical, or it is asymmetrical, or you can say it is skewed as well. On to question 4. So it says the weights of the male leopards in a particular region are normally distributed with mean 55 kgs and standard deviation 6 kgs. Find the probability that a randomly chosen male leopard from this region weighs between 46 and 62 kgs. So the first thing we need to do is to assign the variable x to be the weight of the male leopard, and that will be x is normally distributed, whereby it has a mean of 55 kgs and a standard deviation of 6 kgs to the power 2. So this means that the probability of x is greater than 46 and is less than 62 is going to be equal to the probability of z is greater than 46 minus 55 divided by 6 and is less than 62 minus 55, which is the mean, divided by 6, which is the standard deviation. And that's going to be probability of z is greater than negative 1,5 and is less than 1.167. So we know that the probability of z is greater than negative a and is less than b is equivalent to the phi of a plus the phi of b, subtract 1, which means that it is going to be the phi of 1,5 plus the phi of 1.167, subtract 1. And using our normal distribution table, our z table in the formula booklet, the phi of 1,5 is going to be equal to 0.9332. And what about the phi of 1.167? So if you look at our z table, we look at the C column first, and in the C column we're going to look for 1,1, and within this area here we're going to look for the value of 6. And what we're going to do is we're going to look at where these two coincide. So that will be 0.8770. And now, using the last digit remaining, which is 7, we look at it in the add region here. So if you look at if you look at 7 in the add region, and where it coincides with 1.1 here, is going to be equal to, it's going to be 14. And the last thing we're going to do is to add 70 and 14, and that will give us an answer of 0.8784. Subtract this one here, and that will be simplified into 0.812. On to the next question. So it says the weights of female leopards in this region are normally distributed with the mean 42 kgs and standard deviation sigma kgs. It is known that 25% of female leopards in the region weigh less than 36 kgs. Find the value of sigma, or the standard deviation. So the first thing we need to do is to assign the variable or y to the weight of the female leopards. So y will be normally distributed with the mean of 42 and a standard deviation of sigma squared. So now what you need to find is the probability of y is less than 36. That will be equal to the probability of z is less than 36 minus 42 divided by sigma, and that's going to be equal to 0.25. So based on our formula booklet, the phi of 0.674 is equal to 0.75. This means that the phi of negative 0.674 is 1 minus 0.75, or 0.25. So what does this mean? It means our value for z is equal to 0, minus 0.674. Therefore, what we can do is we equate our value for z for this expression here with this expression here. So 36 minus 42 divided by sigma is going to be equal to minus 0.674. And if we make sigma the subject of the formula, what we're going to get is 8.9. On to the next question. So it says the distribution of the weights of the male and female leopards are independent of each other. A male leopard and a female leopard are each chosen at random. Find the probability that both the weights of the leopards are less than 46 kgs. So what we need to do is we need to find the individual probability for the male and females such that they are less than 46 kgs. So starting with the males, so the probability of males less than 46 kgs, or probability of x, because we made x the variable, is less than 46. That will be equal to the probability of z is less than 46 minus 55 divided by 6, and that will be equivalent to the probability of z is less than negative 1.5. So that's the same as 1 minus phi 1.5, which is 1 minus 0.9332, and that will simplify into 0.60668. Now, for the probability that the female is less than 46, it's going to be equal to the probability of z is less than 46 minus 42 divided by 8.9, which is the standard deviation which you found from the previous question. That is equal to the phi of 0.449, And using Z table from our booklet, we find the value of 0.6732. So since both these probabilities are independent, it means that the probability of having both male and female is going to be 0.0668 multiplied by 0.6732. On to question 5. So it says a group of 12 people consists of 3 boys, 4 girls, and 5 adults. A. In how many ways can a team of 5 people be chosen from the group if exactly one adult is included? So if one adult is included out of the 5 people, it means that the remaining 4 are going to be the children, which are the girls and the boys. So our arrangement will look like this. So we have an adult, and here we have the remaining children. So for the adults, we're going to choose one adult out of the 5 adults. So it will be 5 combination 1. And as for the children, we have a total of 4 plus 3 children, which is 7. But for the 7 children, we're only going to choose 4. So here is going to be 7 combination 4. So the number of ways the 5 people can be arranged is going to be 5 combination 1 multiplied by 7 combination 4, which is 175 ways. On to question 5b. So it says, in how many ways can a team of 5 people be chosen from the group if the team includes at least 2 boys and at least 1 girl? So since there should be at least 2 boys, there's only going to be 2 outcomes for boys. They're either going to be 2 boys or they're going to be 3 boys, which is the maximum number of the boys. Whereas for the girls, there's either going to be 1 girl, 2 girls, or 3 girls. So based on that information, what I can get is we can get 2 boys, 1 girl. That leaves us with 2 people remaining, which will be the 2 adults. So the arrangements for these 3 is going to be 3 combination 2 multiplied by 4 combination 1 multiplied by 5 combination 2, and that will be equal to 120 ways. Whereas if you have 2 boys and 2 girls, and that will leave us with 1 adult for them to add up to 5. So it means that our arrangement for this is going to be, out of 3 boys, we choose 2 multiplied by 4 girls, choose 2 multiplied by 5 adults, choose 1, and we're going to have 90 ways. And we can also have 2 boys and 3 girls. So we're going to have 3 combination 2 multiplied by 4 combination 3, and that will be equal to 12. Or we can have 3 boys, 1 girl, and that leaves us with 1 adult. So it means we have 3 combination 3 multiplied by 4 combination 1 multiplied by 5 combination 1, and that will be equal to 20. And the last one, we can also have 3 boys and 2 girls. So this is going to be 3 combination 3 multiplied by 4 combination 2, and that's going to be equal to 6. So this means the total number of ways is going to be 120 plus 90 plus 12 plus 20 plus 6, and that will be equal to 248. Onward to question 5c. So it says, how many different arrangements are there in which three boys stand together and an adult is at each end of the line? So our arrangement is going to look something like this, where we have an adult at each end and we have the boys which are together, highlighted in blue. So since the boys are together, we're going to regard them as a single entity. So we're going to count them as one here, right here. So look, first things first, looking at the adults, we can see that the adults can only have two available slots right here. So out of 5 people, there's going to be only two slots being available. So it means the number of different arrangements for the adults is going to be 5 permutation 2, or 5 times 4, which is equal to 20, because for the first end right here, there can be only be five choices, and for the other end we're going to have 4 choices. So 5 permutation 2 or 5 times 4. Now looking at the children, we said that we're going to count the boys as a single entity. So this means that the total number of arrangements for the children is going to be 8 factorial. However, we need to consider the internal arrangement of the boys. So the internal arrangement of the boys is 3 factorial. Therefore, the overall arrangements in which the boys stand together and the adult is at the end of each line is going to be equal to 5 permutation 2 multiplied by 8 factorial multiplied by 3 factorial. Or you can say 5 permutation 2 multiplied by 8 permutation 8 multiplied by 3 permutation 3 will be equal to. On to question 6. So it says a factory produces chocolates in three flavors: lemon, orange, and strawberry, in the ratio 3:5:7 respectively. Neil checks the chocolates on the production line by choosing chocolates randomly, one at a time. A. Find the probability that the first chocolate with lemon flavor that Neil chooses is the 7th chocolate that she checks. So the first thing that we need to do is to find the probability of getting the lemon flavor. So that will be equal to 3/15, which can be simplified to 1/5. This means that the probability of not getting the lemon flavor, or the probability of getting other flavors, is going to be 4/5, or 1 minus 1/5. So since Nell chooses the lemon flavor on her 7th attempt, this means that she did 6 attempts without getting the lemon flavor. So our probability is going to be 4/5 to the power of 6 multiplied by 1/5, and that will simplify into 0.0524. Now on to question 6b. Find the probability that the first chocolate with lemon flavor that Nell chooses after she has checked at least 6 chocolates. So that will be the probability of 7 plus the probability of 8 plus the probability of 9, and so on. So probability of 7 is the probability that she had checked 7 chocolates and got the lemon flavor on the 7th attempt, and the probability of 8 is the probability that she checked 8 chocolates and she got the lemon flavor at the 8th attempt, and so on. So that will be equal to 4 over 5 to the power of 6, because this means she did 6 attempts without getting the lemon flavor, multiplied by 1 over 5, which is the probability that she got the lemon flavor, plus 4 over 5 to the power 7, which means she did 7 attempts without getting the lemon flavor, multiplied by 1 over 5, plus 4 over 5 to the power of 8, which means she did 8 attempts without getting the lemon flavor, multiplied by 1 over 5. So if you look at the sum of these probabilities, you can see that it follows a pattern of a geometric progression with a common ratio of 4 over 5. So since the common ratio is 4 over 5, it means that this sum of the probabilities has a sum to infinity. So we know that the sum to infinity is equal to the first term divided by 1 subtract the common ratio. So in this case, our common ratio is going to be 4 over 5, and the first term is going to be the probability of 7 right here, which is 4 over 5 to the power 6 multiplied by 1 over 5. This means that our probability right here can be simplified into 4 over 5 to the power 6 times 1 over 5, which is our first term, divided by 1 minus our common ratio, which is 1 minus 4 over 5, or 1 over 5. This 1 over 5 will now cancel with that 1 over 5, and we are left with 4 over 5 to the power of 6, and that can be simplified, and that can be written as 0.262. On to question 6c. It says Petra has a box of surprise chocolates. She chooses 3 chocolates at random from the box. She eats each chocolate before choosing the next one. Find the probability that none of Petra's 3 chocolates has orange flavor. So the probability of not getting an orange flavor is going to be equal to 1 subtract the probability of getting an orange flavor. So it's going to be 1 minus 5 over 15, and that is going to be equal to 10 over 15. 10 over 15. So that will be the probability of getting the first chocolate that is not orange. And the probability of getting the second chocolate that's not orange is going to be 9 out of 14, because 1 chocolate has been eaten. So we're only going to be left with 9 chocolates that are not orange. So it's going to be 9 over 14. And the probability of selecting this third one that is not orange flavored is going to be 8 over 13, because 2 of the chocolates have been eaten. So we're only left with 13 chocolates, and only 8 chocolates will be remaining that are not orange. So it will be 8 over 13, and that will give us a value of 24 divided by 91, which is also equal to 0.264. On to question 6d. So it says, find the probability that each of Petra's 3 chocolates has a different flavor. So we're going to have 3 chocolates that have different flavors. So it's going to be strawberry, lemon, and orange. So it's going to be the probability of having a strawberry flavor multiplied by the probability of having the orange flavor, which is going to be 5 over 14, because we have already chosen 1 chocolate, so we're only left with 14. We're going to be left with 14 chocolates left to choose, multiplied by the probability of getting the lemon flavor, is going to be 3 divided by 13, because 2 chocolates have already been chosen, so we'll be only left with 15 minus 2, or 13 chocolates, multiplied by the number of different arrangements of the chocolates, which is going to be 3 factorial, and that's going to be equal to 3 over 13, or 0.231. On to question 6e. So it says, find the probability that at least 2 of Petra's 3 chocolates have strawberry flavor, given that none of them has orange flavor. So this is a conditional probability. So it is the probability that there's at least 2 strawberry chocolates out of the 3, given that there's no orange flavor. So that's going to be equal to the probability of having at least 2 strawberry flavors out of the 3, and there's no orange flavor, divided by the probability of having no orange flavor. So for the top one, the probability of having more than 2 strawberry flavors and there's no orange flavor is going to be either we have 3 strawberries, which is S, S, and S, or we have two strawberries, so which is S, S, and the other flavor, which is not the orange flavor, which is lemon flavor. So it's going to be the probability of having all strawberry flavor is 7 over 15 multiplied by 6 divided by 14 multiplied by 5 over 13, because we have 7 strawberry flavored chocolates, and here we have 6 remaining, and here we have 5 remaining as well. And we're going to add that with the probability of having 2 strawberries and the other flavor, which is lemon flavor. So it's going to be 3 over 15, which is the lemon flavor, multiplied by 7 over 14, which is the probability of having the strawberry flavor, multiplied by the probability of having the strawberry flavor again, which is 6 divided by 13, multiplied by the number of different arrangements which we can get from 2 strawberries and 1 lemon, which is 3. And this is going to be divided by the probability of having no orange flavor, which is going to be 24 over 91, which is coming from the previous question 6c. And this is going to be simplified into 49 over 60, and that's going to be equal to 0.817.